base is higher than the strength of the acid. I told you that when the strength of a base is higher than the strength of the acid, what are you expecting? A basic solution. Now, how about if the strength of the base is less than the strength of the acid? Because Kb and Ka are just indicators of the strength of the acids and the strength of the base. So when the strength of the base is less than the strength of the acid, we should be expecting an acidic solution. And then whenever Kb, which is strength for anion, is equal to or approximate to that Ka for cation, the solution is said to be what? Neutral. So this is one way to see in a situation where both anions and cations are hydrolyzed. Now these are important questions you may come to see in objective. You say when Kb for anion is less than Ka for this thing, the solution is said to be acidic. They may say which of the following is true, and then they gave you this, gave you this, gave you this, and then twist one like that, that you know that that one is not correct. Is that okay? Now that is easy to understand. All right, now let's look at hydrolysis. Now when we talk about, before we talk about hydrolysis, you have some examples of salt here that we are actually given, and there are some examples of salt that are given, types of salt, examples, and the ion that undergo hydrolysis. Now I told you that when you have something like this, look at it, it's very easy. They may ask you which of the following ion can undergo hydrolysis. You have Ki, you have KNO3, you have ROB, BRO, BaCl3. What kinds of salts are these salts you have here? They are neutral salts. Why do you think that they are neutral salts? Look at it. I told you that neutral salts comprise of group 1 elements or group 1 metals and then the conjugate base of strong acid. The conjugate base of strong acid are chlorine, iodine, nitrate, and so on. Chlorine, iodine, nitrate. Those are basically the conjugate, even bromine, conjugate base of strong acids. Alright? So when you have a group 1 metal and the conjugate base of those strong acid, you should be expecting a neutral solution or a neutral salt. Example, if you look at this is sodium. Sodium is group 1. This is a conjugate base of strong acid. Potassium is group 1, conjugate base of strong acid. Potassium is group 1, conjugate base of strong acid. This rubidium, I think, is group 1, conjugate base of strong acid. And then barium is group 2, conjugate base of strong acid. Is that okay? So everything here you have neutral solution. And I told you that for neutral solution, neither the positive ion nor the negative ion is hydrolyzed. Are you getting it? Neither of them is hydrolyzed. And hence, what are you expecting the pH of the solution to be? The pH should be approximately what? 7, because it will be neutral. Now, how about if the cation is from a strong base and the anion is from a weak base? It's more like what you have here. Kb, the Ka for cation, or let's say, yeah, Ka for the cation. Kb for anion is less than Ka for cation. It means that the cation is a strong acid while the anion is a strong base. Examples of such compound is you have or examples of such compounds you have ammonium chloride and ammonium nitrate. Now, my dear students, let's look at it critically. Ammonium chloride. Now, this chlorine here, right, is an anion from a strong acid. Are you getting it? Yeah, it's a cation from a strong acid rather. No, this is not a cation from a strong acid. It's not the cation from the cation is from ammonia. Ammonia is a weak base, and then the anion is from a strong acid. Look at it, because this chlorine is from ACl. I think there was some kind of mistake here. Cation from weak base, anion from strong acid. Yeah, it's correct. Cation from weak base, anion from strong acid. Because if you look at this ammonia is from, ammonium is from ammonia. Ammonium is a weak base, right? While the anion is from chlorine. Chlorine will give us ACl, which is a strong acid. Are you getting it? Now, that kind of solution is going to form an acidic solution. It's going to form an acidic solution. So they gave you some examples of such compounds here. Just go through them. All right? Beautiful. So that is that. Now, we want to look at three scenarios. There's something under hydrolysis. We want to look at three scenarios. You have the dissociation of water, right? Water is H2O. When water dissociates, it's going to form H plus plus what? OH negative. What is our Kw for water? We say Kw is the same thing as what? H plus and OH negative. I have explained this to yours before, right? Now, how about if you have a let's say reaction where you have the acetic acid. If acetic acid dissolve in water, I told you that in equilibrium constant expression water does not show. This is going to form the acetate ion. Now, in your material, this acetate ion, so that you not get confused, is represented as AC negative, right? While the acetic acid is represented with what? HAC, so that you not get confused. All right. Now, what do you think is the acid dissociation constant for this? Ka would be the concentration of CH3COO negative, then concentration of what? H plus, divided by the concentration of acetic acid. Now, let us look at another case where you have ammonium hydroxide. Now, when this dissociates in water, it's going to form the ammonium ion plus OH negative ion. What do you think our Kb for this case will be? It will be the concentration of ammonium ion divided by concentration of hydroxyl ion, everything here divided by concentration of, the ammonium ion. Now, you can also see that at the end of the day, Kh for hydrolysis, this is a formula that you should know, is equals to our Kw, which is the acid dissociation constant, divided by Ka times Kb. How do we prove this? Our Kh for hydrolysis, that means when you hydrolyze the ions that are formed, are you getting it? What you formed is still the same thing as Kw divided by Ka times Kb. How do we prove this? It's very, very easy. Now, but it's very, very easy. It's very, very easy. But since you didn't prove it in your material, there's no need of actually going there. Now, at the end of the day, if you take pKa, of course, you know, if you take negative logarithm of everything you have here will become what? pKh will be equals to pKw. In chemistry, or generally in mathematics, when you have division sign like this and you know this pk, it means you are using minus log to multiply through. So it means you use minus log to multiply everything here. This is going to give a pKw minus the same thing, pKa, then plus pKb. Now we can actually prove this, but I don't think there is any need for us to prove that. But we can actually prove it. Are you getting? Because in mathematics, if we take minus log of everything here, if you want to write this, you write this as minus log KH is minus log KW. You know, in division mathematics, if you are writing log and there's division, it change to negative sign. Are you getting it? So you have minus bracket. Everything here will become minus log KA, then another this is supposed to be positive, right? Minus log KA, and then you have minus log KB. All right, so that at the end of the day, when you do your mathematics, this is going to give minus log KH. This is in as what? PKH. Minus log KW. This is in as PKW. Is that okay? Then you have minus log KA is going to give us PKA. Then also, are you getting it? The next one is this bracket minus log KB is going to give us what? PKB. Are you getting it now? So that is what they have here. This is supposed to be in bracket for this equation to be correct. So PKH will be PKW minus bracket PKA plus PKB. That was what you have there. I really don't think there is any need for you to know that. So now let us look at a buffer. What is a buffer? A buffer is the solution of a weak acid and its salts to form an acidic buffer solution, or a weak base and its salts to form a basic buffer solution. So you can say that a buffer solution is a solution of a weak acid and its salt, or a solution of a weak base and its salt. If it's a solution of weak acids and its salt, the kind of buffer is going to form will be acidic buffer. If it's a solution of weak base and its salt, is going to form a basic buffer. Now, a buffer has the capacity to resist change in pH. The body, the biological system, is made up of buffer. Now, this buffer have the capacity to resist a change in pH. So that is why the buffer system in the body is what is responsible for regulating our blood pH and our body pH. I know the blood pH is around 7.4. It's almost tending towards alkalinity or basicity, right? That is the blood pH. Now, buffer play important role in our biological systems and in physiology of the human body. I get it now. There are several buffer systems in our body. Worthy of mention is the carbonic acid buffer, or the carbonic acid buffer. All right. So a buffer is a solution of a weak acid and its salt to form acidic buffer, or a weak base and its salt to form a basic buffer. Now, when you say something is a buffer, it means that it's actually resist a particular force. If you put an acid in the body, let's say you get too much acid or acidic substance, this buffer is what is responsible for neutralizing this excess acid and making the body to fall back to this normal pH of 7.4. Is that okay? Now, that is what a buffer solution is. Now, there are two types of buffer based on the composition, based on the definition we've given here. We have the acidic buffer and we have the basic buffer. They resist a change in pH. Acidic buffer will consist of a what? Weak acid and the conjugate base of that weak acid, or you can say weak acid and the salt of that acid. Some persons will say the conjugate base, but let's just take it as the salt of that acid. While basic buffer will consist of a weak base and the salt of that base. Are you getting it now? Now let's take the first one, acid buffer. Now, what is acidic buffer? They are buffer which have pH around, the pH is around 4 and 7. Are you getting it? In between 4 and 7. Now, we said it can be prepared from a weak acid and the salt of that weak acid, or sometimes some persons call it the salt of the weak acid is called the conjugate base. All right, can be formed from the weak acid and the salt of that acid, which I said some cases we call it the conjugate base. So please indicate this as a weak acid. Buffers are not formed from strong acid. So when you have a mixture of a weak acid and the salt of that acid, it gives you buffer, an acidic buffer. Example is an aqueous mixture of ethanoic acid. Ethanoic acid is CH3, is a weak acid. So when you mix ethanoic acid and sodium ethanoate, it forms an acidic buffer. This is the conjugate base. This is the salt of this weak acid. Is that okay? That is the salt of this weak acid. Now, what actually happens in this reaction? Both acetic acid and sodium ethanoate will hydrolyze in water, right? Now, when they hydrolyze in water, this is going to give us CH3, COOH. If this one hydrolyze in water, it's going to give us CH3, COO negative plus what? H plus. Plus H plus. All these are aqueous solution. Alright, so you must indicate. Now also, this one here, this salt will also hydrolyze in solution to form this aqueous. Now you see that both of them form the same negative ions, but different positive ions. Now what happens if a small amount of acid is added to the solution? What do you think will happen when small amount of acid is added to the solution? So if you add a small amount of acid, let's say you take this particular one. You know these whole ions, everything they are in solution. If you add a small amount of acid, what do you think will happen? Now what will happen is that this ion here will neutralize that acid. Are you getting it now? It's going to neutralize that acid. So if you add, let's say this is I told you that the buffer comprises of these two things in solution. So these are the ions you have in the solution. Everything is okay. But if you add an excess of H+, because what actually makes this thing to be acidic is because of the presence of this H+ here. Are you getting it? That is what makes this to be what? Acidic. Because of the presence of that H+. So if you add excess of this H+, what will happen, according to the Le Chatelain's principle, that when there is a shift in the equilibrium, you know this thing is in equilibrium normally. When you add an excess and there's a shift in the equilibrium, this CH3COO negative will consume the excess H+, and the equilibrium will shift to the left. This is something that most of you need to have known, but some persons still don't know the Le Chatelain's principle, because you are going to use those ideas here. So what we are saying is that forget about this one. This one is normal, is present in the solution. But if there are excess of H+, this ion here will be the one to come and fight this H+ and eat it off. Are you getting it? So when it eats it off, it's going to form CH3COOH. And you know that this thing is what? Is neutral here. Because this one, it means that there are no excess of H+ ion in solution. Hence you call that an acidic buffer. Are you getting it now? Because it helps to actually chop up what? Acid. The same thing applicable if you put OH negative in solution. What will happen is that this ethanoic acid itself will react with the OH negative. That is, if there is excess of base, OH negative means excess of base now, will react with the OH negative. And what do you think can actually happen? Ethanoic acid will be acting as an acid here. It will donate a proton. And when it donates a proton, what are we expecting? We are expecting to have CH3, COO negative plus what? H2O. So in this regard, you can now see that the excess of OH negative was chopped off to give us this acetate ion and water, which are neutral. I told you that the only thing that makes something to be acidic or basic is the presence of what? H plus and what? OH negative. So what this buffer are trying to fight against is if there are excesses of H plus and OH negative, what will happen? If there is excess of H plus, the acetate component, which is this negative ion component of the buffer, will what? Will react with that excess acid. This H plus you have here is the excess acid, and then neutralize it, bringing the pH back to normal. Because the presence of this excess acid will raise the pH, or decrease the pH rather, because when you talk about decrease the pH and make the solution to be what? Acidic. Do you understand the concept? It will decrease the pH and then make the what? The solution to be what? Acidic. Is that okay? Good. So what we are looking at for, we are looking for excesses of H plus, because we know excesses of H plus will make the solution to be acidic, and what? Excesses of OH negative, because we know that excesses of OH negative make the solution to be what? To be basic. Do you grab the concept now? So that is how the buffer solution work. So what we are looking for in the buffer solution is, we said it contains what?